Welcome to this explainer. Today, we're not just throwing dry astronomical facts at you. We're going on a massive narrative journey. We're talking about the story of us. We'll be exploring humanity's profound, terrifying, and honestly beautiful relationship with the cosmos. We're going to look at our fragile little place in the universe through some of the most mind-bending discoveries we've ever made.
So, let's kick things off with a slightly terrifying thought experiment. Okay? Picture this. You walk outside, look up, and the moon is just tumbling toward us at an astonishing speed. It sounds exactly like a sci-fi disaster movie, right? But running the actual physics on this scenario paints a deeply fascinating picture of the cosmic forces at play right on our doorstep.
If this actually happened, the destruction would be, well, completely apocalyptic, but it would end in a surprisingly beautiful way. First, the shifting tides would literally cause oceans to rise up and swallow coastal cities whole, and our satellites would just get violently whipped out of orbit. But here's the crazy part. Before the moon could even hit the surface, right around 11,000 miles away, Earth's gravity would literally tear it to pieces. Any survivors would look up and see these gorgeous, shimmering rings, kind of like Saturn's, raining moon dust down on us every single night.
But back in reality, the exact opposite is happening. The moon is actually inching away from us by 1.5 inches every single year. So no, we don't have to worry about a lunar collision, but this slow retreat has a massive impact on our timeline. Because as it pulls away, the Earth's rotation is actually slowing down. Our days are getting longer. To put that in perspective, in a billion years, a single day on Earth will stretch to 28 hours. You could finally get a full night's sleep and still have 20 hours left to do whatever you want. All right, let's jump from Earth over to our neighbor Mars. The rovers over there have shown us something wild. Because of the fine Martian dust, they get these stunning, eerie blue sunsets around a sun that looks way smaller than ours. Since Mars is further away, the sun just shrinks in the sky. And unlike our atmosphere, which scatters light to give us those warm pink and red evenings, that superfine Martian dust actually lets blue light penetrate way more efficiently. It's a hauntingly beautiful reminder of how completely different yet strangely familiar other worlds can be.
Moving on to Section 1, Pioneers in the Abyss.
To leave our immediate neighborhood, we have to confront some incredible isolation. Imagine the absolute dead silence astronaut Bruce McCandless experienced back in 1984. He was floating a full 100 meters away from his ship, testing a space jetpack, completely untethered. No rope, just him, alone in the abyss. It's honestly terrifying to even think about. Yet, the vast emptiness wasn't the scariest part for him. The only thing that really terrified him was the intense, biting cold that gripped him the exact second he drifted away from the shuttle. And that chilling reality really highlights the tragic sacrifices made in our earliest attempts to explore the cosmos. Take Laika, for example. She was a stray dog sent on a one-way trip during the Soviet space race in 1957. Back then, we had literally no idea if a biological body could even survive zero gravity. So Laika was taken straight from the streets of Moscow, strapped up with sensors, and put into a tiny cabin basically the size of a washing machine. The poor thing probably thought she had finally found a home.
She was absolutely terrified during the launch. Her heart rate tripled, and the cabin quickly reached a fatal 40 degrees Celsius, or 105 degrees Fahrenheit. It ended her life after just 6 hours in orbit. The scientists fully knew they were sending her to her grave. It's just a heartbreaking, incredibly heavy price that was paid in that desperate rush to win the space race and unlock the stars for us.
But that emotional weight isn't just limited to living things. It was captured so perfectly, decades later, by the final message of NASA's Opportunity rover. A massive Martian dust storm choked out the sun after her 14 incredible years of survival. Get this, Opportunity was only designed to last 90 days. Instead, she crawled 28 miles across Mars for over a decade. When that storm finally covered her solar panels, her fading transmission home saying, "My battery is low and it's getting dark," felt so deeply human. It marked the heartbreaking end of a truly resilient explorer. This brings us to Section 2, Cosmic Leviathans. So from our fragile pioneers, we now venture outward into a universe filled with objects of just incomprehensible scale. Take the red giant star Betelgeuse. It's currently fusing carbon in its final end stages, and when it explodes, hopefully in our lifetime, it will literally cast shadows on Earth in the dead of night. Betelgeuse has actually been acting kind of erratic recently, getting brighter and dimmer. And since it's 500 light-years away, well, this explosion might have technically already happened. But don't worry, we are at a safe distance. If we were just a little bit closer, a supernova like this could wipe us out, but instead, we're just in for an unbelievable light show. Now, even deeper in space, black holes collide and create what we call gravitational waves. These are massive ripples in the actual fabric of space-time, traveling at the speed of light. Einstein predicted them, and we finally detected them back in 2015 using LIGO's 4-kilometer-long lasers. Just imagine dropping a stone into a pond, except the pond is the fabric of space and time itself. These ripples stretch and squeeze literally everything in their path. It took splitting a laser beam down a set of 4-kilometer-long mirrored arms just to detect the microscopic change caused by these waves passing through Earth. Unbelievable, right?
And speaking of black holes, to actually take a picture of these elusive light-eating monsters, scientists had to get incredibly creative. They basically had to turn our entire planet into one giant camera lens. Since black holes emit absolutely no light, unless they're actively eating matter to form a glowing disk, getting enough resolution to see Sagittarius A star in our Milky Way or the monster M87 meant linking up telescopes all over the globe. The result of that massive Earth-sized array, real, literal photographs of the unseeable.
But honestly, nothing compares to Phoenix A star. This is a terrifying black hole 8.5 billion light-years away that is a staggering 100 billion times larger than our sun. Let that number sink in for a second. The human brain literally struggles to comprehend math like that. 100 billion times larger than the star that warms our entire planet. It's actually a single object that is bigger than some entire galaxies.
To really grasp this monster's scale, you have to look at its event horizon. You know, the point of no return where even light gets sucked inside. Its event horizon is so vast that even if you were traveling at the speed of light, the absolute speed limit of the universe, it would take you 71 days just to loop around it once. 71 days. And the scariest part, it is still growing.
And finally, we arrive at Section 3, Echoes and Dust.
After facing the crushing, terrifying scale of the cosmos, let's bring this epic journey back to us, on a much more personal level. Amidst all those exploding stars and galaxy-swallowing black holes, we've really tried to leave our own tiny mark on the dark. When NASA launched the Voyager probes in 1977, they included the Golden Record. It's this beautiful time capsule expertly put together by Carl Sagan's team to tell the human story to, well, anyone who might find it out there. It carries the sounds of our world, greetings in dozens of languages, nature sounds, and music. It is quite literally humanity's message in a bottle tossed into the cosmic ocean.
Decades later, in 1990, as Voyager 1 was leaving our solar system way out past Neptune, Sagan convinced NASA to turn the camera around and take one last image of Earth from 4 billion miles away. Now, some people thought it was a huge waste of precious fuel just to take a picture of empty space. But what it captured was absolutely profound. Caught right there in a scattered ray of sunlight was a single microscopic pixel, the pale blue dot. As Carl Sagan profoundly noted about that tiny pixel, the Earth is the only world known so far to harbor life. Look again at that dot. That's here. That's home. That's us. Every human being who ever was, every empire, every loved one, every triumph and tragedy in all of human history lived out their lives on that tiny mote of dust suspended in a sunbeam. It fundamentally shifts your perspective on what really matters, doesn't it?
Yet, while we might seem incredibly small on that little blue dot, we are intimately tied to this grand cosmic story. Every breath of air you take was formed in the heart of a dying star. Every glass of water traces its lineage straight back to the Big Bang. The cosmos isn't just out there. It is literally inside of you. You are a walking, breathing piece of universal history.
You, quite literally, made of stardust. Which leaves us with one final, deeply profound thought to carry with you today. As you look up at the night sky, are astronomy and physics simply how the universe gets to observe itself? Are we just the universe finally waking up to look back at itself? We are a way for the cosmos to know itself. Thank you so much for joining me on this explainer today. Keep looking up and keep wondering.